All right, Mathletes 1.4, parallel lines and perpendicular lines. So big thing today, make sure you remember the general form is ax plus by equals c. This is very useful when we're dealing with x and y intercepts to find them, or if we're given the x and y intercepts, this is the easiest form to put it into. Today our big thing we're talking about is parallel lines. We know two non-vertical lines are parallel if and only if. So that means they must meet this condition if their slopes are equal. For perpendicular lines, if their non-vertical lines are perpendicular if and only if the product of their slopes is -1. So that's going to be opposite reciprocal slopes. So if you have a slope of 1/2, the opposite of that is -1, and the reciprocal of that is -2/1. So this slope would be perpendicular to this slope. Notice if you find the products of those two, it equals -1. So change your sign, flip your slope, and those will be perpendicular for you. All right, so let's look at some examples here. Show that the given lines are parallel. So in order to show these lines are parallel, it must meet the condition that their slopes are the same. So because they're in this general form, I want to simplify them and put them into a form where I can identify the slope easiest. For me, it's going to be our slope-intercept form. So to get that, I need to get y by itself. Isolate that, so subtract 3x from both sides. And I get y is equal to -3x plus 12. So my slope is -3. On L2, again, I need to isolate this y. So first thing I'm going to do is peel away 6x. So I get 2y is equal to 6 minus 6x, and divide by 2. Divide by 2, I get y equals, reverse the order here, so I get -3x plus 3. So again, all I'm concerned with is the slope here. M is equal to -3. These are the same, so therefore L1 is parallel to L2. All right, so if we look at 2, find an equation of a line that contains the point -3, 9 and is parallel to the line 2x plus y equals -8. Well, to find a line containing a point, that tells me I'm probably going to use point slope form. So if this is my x1, y1, I know I'm going to have y minus 9 is equal to m x minus a -3 here. Well, the only value I need to still find is my m, and I'm going to get that from this information. So I want it to be parallel to this, so it needs to have the same slope. So I need to identify the slope in this line as I did in example 1. So I need to get it into point slope-intercept form so that I can identify what my slope is. So get my y by itself. So subtract 2x from both sides. I get y is equal to -2x minus 8. This slope is -2, which should also be that slope. So as I plug that in here, I get y minus 9 equals -2 times the quantity, x plus 3. I'm just going to leave it there in point slope form. It's not telling me what equation, what form it needs to be in, so I might as well just leave it here and not make any mistakes trying to put it into a separate form. Next example 3, what is the slope of a line that's perpendicular to 8x minus 6y equals 12? So again, I know my slopes need to be opposite reciprocals, so I first got to identify my slope from this equation. To do so, I'm going to isolate my y. So I have 8x minus 6y equals 12. Subtract 8x from both sides. I get negative 6y is equal to negative 8x plus 12. Divide by negative 6. Divide by negative 6. Get y is equal to, negatives are going to cancel out, and 8, 6 reduces to 4/3 x minus 2. So here is my line. So if I want to know the slope of a line that's perpendicular, if m here is 4/3, I need to find m primed such that m times m primed equals -1. Like I said before, it's opposite reciprocals. So first, make it opposite. So it was positive 4/3 before. Now it must be negative, and reciprocate it, and I get 3/4. So this must be the slope of a line that's perpendicular to that line. To verify this, I can do 4/3 times -3/4, and I see that's equal to -1. All right. So here's our next example here. Find an equation of a line that contains the point 2, -4 and is perpendicular to the line 2x plus y equals -8. Again, I have a point here, 2, -4. So if I have a point and I want an equation that contains that point, I'm going to use the slope point form. Again, x1, y1. I get y minus a -4 is equal to m times the quantity x minus 2. Still needing my m. Where is that going to come from? Well, I need to find a line that slopes perpendicular to this line. So first identify the slope of that line. So put it into slope-intercept form, isolating your y. So I'm going to have 2x plus y equals -8. So then I get y is equal to -2x minus 8. This slope, m1, is equal to -2. So I need to make sure I find the opposite reciprocal. So m, that's perpendicular to m1. So m has to be opposite, so it's negative of a -2, and it's got to be reciprocal. So I'm also going to flip it. So you can think of this over 1. So as I flip it, I get 1/2 negative. So the final answer should just be a positive 1/2. It's opposite of a -2, and it's reciprocated. I can see that -2 times 1/2 is equal to -1. So here is my slope. Now I just substitute it in over here, and I get y plus 4 is equal to 1/2 times the quantity x minus 2. Okay, there is my equation that contains this point, but is perpendicular to this line. All right, that's our last example in our notes for tonight. Highlight any questions you have and bring them to class tomorrow. Thank you.